So all things have electrical charges. Neutral charges occur whenever the number of protons and electrons are equal. So protons have positive charge, they're at the center of the atom, and electrons have negative charges. Building a charge, materials such as carpet or hair loses electrons easily and transfers electrons. Where? That's a 1. Y'all quit talking. Static electricity is the accumulation of excess electrical charges on an object. So whenever you rub two materials together, you can knock some of the electrons off of one object and put it on another. So one object becomes slightly positively charged, and the other object becomes negatively charged. I have a Van de Graaff generator that we'll play with this week, I think. It's a device for producing high voltage static electricity. Yes. And I will let y'all shock yourselves if y'all want. It won't hurt. Alright, it won't kill you. It will. Keep your mask on, Michael. So what a Van de Graaff generator is we have basically like a giant big rubber band, a rubber belt, and we have some teeth, some metal like forks that rub against the rubber. And the rubber is on a belt and a motor pulling it around, and we have these metal teeth like on a kind of like a fork or a cone, constantly rubbing on it. As the rubber slides across the fork, electrons come off and hit the metal, and because the metal is conductive, it allows electrons to flow around it, and we end up creating positively charged and negative charged densities. A wire fence is metal or conductive. You can bend metal. Have you ever seen a paperclip? Have you ever seen a paperclip? So, law of conservation of charge. The law of conservation tells us that it applies to charges too. Charges can't be created or destroyed, only transferred. Opposite charges attract. So two negative charges, two electrons will, an electron and a proton will attract each other, and like charges repel. So two electrons will repel each other, and an electron and a positive charge will attract each other. Electric fields are also surround every charge. So conductors and insulators. This is referring to electrical conductors and electrical insulators. We also have thermal conductors and thermal insulators, but this is referring to electricity now. Electrical conductors allows electrons to move easily. Metals are examples of good conductors. Semiconductor is a material such as silicon and germanium that's neither a good conductor nor an insulator. Only can be used as a conductor if impurities are added. This is how cell phones and computer chips work. Is they have silicon and they add some impurities to it to control how much it can conduct. You don't want the electricity to flow through the entire phone. You want to travel in certain pathways. Insulator is a material that does not allow electrons to move easily through it. Lightning is a static discharge. Static discharge is a sudden transfer of electrical charges through air between two objects because of a buildup of charges. So, how lightning works is we have different layers of cloud. We have water vapor is what makes up clouds, and some of the electrons from the top layer go down to the bottom layer and make it more negatively charged. And we end up having some of the electrons from the ground also go up and combine, making the bottom layer negatively charged, and the ground slightly builds up a positive charge because it's missing some electrons. Whenever these two charges, the charge of the bottom cloud and the charge of the ground, becomes great enough, we can suddenly have all the electrons fly downward, and this creates a lightning bolt. It's fast enough that the air gets heated so quickly that it creates a shock wave. This is what we hear as thunder. It's caused by the air heating up so quickly that it moves out of the way and creates a sonic boom. So lightning happens when the negative charges, the electrons in the bottom of the cloud, are attracted to the positive charges in the ground. It's technically not really attract. So again, in order to have a charge, let me write that. So to be negatively charged means you have, for an atom, to be negatively charged means it has more electrons than protons. If an atom loses an electron, it becomes positively charged. We're at this one. Protons means it has more electrons than protons. So charged means it has more protons than electrons. So for an atom to be negatively charged just means it has more electrons than protons. And for it to be positively charged means it has less electrons than protons. So positive charge is less protons, or less electrons than protons. It's not really being attracted to the proton, it's being attracted to a positively charged atom. The accumulation of electrical charges has to be great enough to overcome the insulating properties of air. When this happens, a stream of negative charges pours downward toward a high point where positive charges have clustered due to the pull of the thunderhead. In case you're curious of what voltages are, so air is considered a good insulator. However, if you crank up the voltage high enough, electricity will flow through insulators. It takes about 30,000 volts of electricity to flow 1 centimeter through air. So if you've ever rubbed your feet on carpet and went over and touched someone and you saw a 1 centimeter long volt of electricity, that's a 30,000 volt electricity spark. So whenever you shock someone, you're producing about 10,000 to 30,000 volts of electricity. So lightning is about 1 billion volts. So the connection is made, and note that it's not protons moving. This is wrong. The protons don't move. It's always the electrons. So this description is wrong. What happens is the electrons rush downward to fill the empty voids in the positively charged atoms. It is at this point we see lightning and hear thunder. A bolt of lightning heats the air along its path, causing it to expand rapidly. Thunder is the sound caused by rapidly expanding air. By heating it up like a hot air balloon. So we can have positively charged, we can have the reverse too, where negatively charged ground, positively charged cloud. Grounding is when you connect an object to earth with a conductor. So you can have a lightning rod or a grounding rod on top of your house, and then physically connect it into the ground. The Earth is a large neutral object, such that if a conductor is connected to the Earth, it will ground out or become neutral. Lightning rods are used in homes to ground them out. So, in order for lightning to occur, there has to be a significant difference in charges. If you hook up a grounding rod and put it on top of your house, the electrons in the ground will go up, and start going into the air more slowly. What happens is you're reducing the difference in charges, and a grounding rod actually repels lightning. What does is allow the electrons it allows the charges to equalize instead of build up. Voltage can be thought of as electrical pressure. A voltage difference is the push that causes charges to move and is measured in volts. So if you have a battery that's 3 volts, what the volts mean is how much it's trying to push electrons. You can think of it kind of like pressure. So charges flow from high voltage to low voltage. If you increase the voltage, you're increasing the pushing power on the electrons. You can think of this. You can think of electricity like water and pipes. Put your mask on, Brett. You can think of it like you have a hose of water, and you have water flowing through it. If you increase the pressure, you're pushing more water to go through it. This is the equivalent of voltage. Voltage is this pushing power. A closed circuit means that it's a connected circuit that allows electricity to go through it. So you have a closed conducting path. The flow of charges through a wire is the electric current. So we have voltage and we have current. Current is the actual flow of electricity, or the flow of electrons. Current is measured in amps. Current is also always the flow of electrons. We never think of protons moving. It's always the electrons that move. So in an open circuit, whenever you disconnect the battery, for example, the electrons stop flowing. So in an open circuit, you have no flow of electricity. Whenever you close the path, you complete the circuit. You now have electricity flowing from the positive terminal into the negative terminal. We'll see here when I go into more depth the reason why. So we think of current as being positive charges moving. This is known as conventional current. So let me write that. When Benjamin Franklin was studying electricity, they had not yet discovered the electron. He assumed that positive charges were flowing. The flow of positive charges is called conventional current. Later today. This is opposite of the actual flow of electrons. So if we have a wire and we have current represented with the letter I, so current would be flowing to the right. Electrons are actually flowing to the left. So we'll be using the conventional current, which assumes that the charges moving are positive, but electrons are negative. So the convention is opposite than what it really is in reality. Electrons actually flow in the opposite direction from current, or conventional current. So if we have a battery with a positive terminal and a negative terminal, current flows out of the positive terminal, but electrons flow out of the negative terminal. So current is going to be opposite to the actual flow of the electrons. Whichever stronger one will push stronger. So again, it's like two people pushing. They're the same, it doesn't move, and you probably would make the battery catch on fire. So conventional current is actually opposite to the actual flow of electrons. So the conventional current is actually in the opposite direction to the actual flow of electrons. We label current flowing from positive terminal going toward or into negative terminal. Electrons, however, are actually leaving negative terminal and going into positive terminal. Keep your mask on. So to use electrical energy, a complete circuit must be made. So you have to have a loop. Circuits typically include a voltage source, that would be your battery, some source of voltage, so they will actually push the electron, a conductor that allows electrons to flow easily, and one or more devices that actually use the electrical energy to do work, whether that's converting the electrical energy into light or using it to turn a motor. We'll go into series and parallel circuits more later. I'll talk about them now. We'll go into more depth later. So a series circuit is one in which there's only one pathway for electrons to flow through. So it has one loop. So current would leave, again, current is opposite to actual electron flow. Current goes from positive terminal into the first light. Then it only has one other pathway to go, and that'll be the next light. And then the light after that, and it'll eventually go back to the battery. So series circuits are used in flashlights and hallway light. Parallel circuits contain two or more branches for current to move through. In the first image, what would happen if you accidentally cut the wire in between the first and second light? So all the lights would go out. So if I cut the wire right here, all the lights would turn off. What would happen if I cut this wire right here? So only the second light would cut off, but also the first and third light would get brighter. Because, yes, there's more electrical current. So the electrical current is being divided amongst 3 different lights. So if I cut the second one, the electrons that were going down into the second one now would go down into the first and third. There is advantages to having circuits in series and parallel. So when you have it in parallel, less electrons or less current makes it through each light, so they all 3 appear dim. In the first case, they would all be at the same brightness and would all be very bright. However, if some issue were to go on and a wire gets cut, they all turn off. In this case, if you disconnect one light, you can actually cause the other 2 to get super bright and even break. We will be learning how to write in circuit notation. So in circuit notation, this is your symbols. A battery would look like this. Note that you would have 3 lamps for that top one. So here we draw them in a single line. That's the symbol for a lamp. Symbol for a battery is going to be like this. The longer side is positive. The shorter side is negative. Most houses are connected in parallel, which means if you disconnect your TV, everything else in your house still works. So here is a switch. So if you push it down, it'll connect it. So the left side is in series. The right side is in parallel. So in a household circuit, we have a neutral, hot, and a ground. Most household walls use 120 volt alternating current, while your washing machine and dryer and stove probably use 220, 240. Fridge, depending on what, is probably 120. We also have fuses. It's basically a very thin piece of metal. And keep your mask on, Thomas. As it heats up, it can melt and break, and thus you can prevent your house from catching on fire by having a fuse. We also have something that doesn't need to be replaced, a circuit breaker. As the current gets hot enough and it gets hot, it causes a physical switch to flip. Whenever your electricity is flowing through wires, it causes the wires to heat up as there's a resistance or friction to it. And we often have to build houses that will stop the current in case it gets too hot. So fuses look like this. It's a thin piece of metal. An electrical fuse contains a small piece of metal that melts if current becomes too high. Too many appliances can use the same used at the same time can cause overheating of the circuit. A circuit breaker is a guard against overheating too. It has a piece of metal that bends when it gets too hot. And when it bends, it causes a switch to flip, opening the circuit. Opening the circuit means turning the circuit off. If a circuit were to trip, if a fuse were to trip, you have to replace the fuse. But we can build it quite small, so things like calculators and voltmeters, small devices that will be handling lots of current, Usually we just put a fuse in them. When it breaks, we just have to replace it. Your house, though, if you hook too many things up to the same outlet, it can trip the breaker, and it allows you to go in and reset it. If the breaker were to fail, your house could catch on fire if too much current goes through the same outlet. Batteries. A battery is a device used to maintain a voltage difference. We have dry cell batteries. A dry cell battery is typically individual batteries, such as AAA. It uses chemistry. There's a positive and negative terminal in each battery, causing a voltage difference. The voltage difference causes a circuit to flow. It's dry. Do not cut up in a battery, as mixing with air could cause it to spontaneously catch on fire. Especially lithium batteries, they catch on fire if you were to open them up. If you shoot them, they produce poisonous gas and fire. A wet cell battery contains two conducting plates made of different metals in a conducting solution, usually sulfuric acid. This is like the battery in your car. Battery in a car has sulfuric acid with two different plates mixed in. And we also can charge it up using an alternator. So resistance. Resistance is the tendency of a material to oppose the flow of electrons, changing electrical energy into thermal energy in light. So every material, except for a superconductor, has some resistance. That means some of the electrical energy is going to be converted into heat. And we can measure this resistance, and we just call it resistance. It uses the Greek letter omega. So resistance is measured in ohms, the Greek letter omega. Thinner wires have greater resistance to electron flow compared to thicker wires. Thicker wires have more metal and more pathways for electrons to flow through. So think of it again, the water analogy. You can think of it as water being pushed down a hose. If you keep your mask on, if you have a very thin hose, you can't get too much water to go through it. If you have a bigger hose and you're still pushing with the same force, more water will flow through it. Longer wires also have more resistance than shorter wires. If you have a long extension cord, you can actually damage some components if you hook it up. For example, when I was a kid, I didn't know this. We had a house behind us with some deep freezers in it, and I hooked up a very long electrical extension cord from a generator during a hurricane up to a deep freezer very far away. Because the resistance was higher because of the length of the electrical cord, it burnt up the motor in the deep freezer. Because the deep freezer was not receiving as much current, and how it worked, it had to ramp up, pull, and some complicated stuff, and ended up burning up the motor. We will not be using E for volts. We will be using V. But we're going to be going over Ohm's law. So Ohm's law. Current is equal to voltage over resistance. So current uses the letter I, and it's measured in amps, which you can just have the letter A. Voltage, measured in volts. You can also have the letter V. So the letter V is going to be the name of the variable and the name of the unit. And we have resistance. It's going to be measured in ohms, which uses the Greek letter omega. So that's the Greek letter omega. By the way, amps is also short. It's an abbreviation for amperes. Amperes is the full word. We usually just call it amps for short. So we have this triangle. Honestly, I remember Ohm's law better like this. Voltage is equal to current times resistance. I call this VIR. Is how I remember this equation. Voltage is equal to current times resistance. So Ohm's law is written like this. I always remember VIR because it's easy to remember the word VIR. V equals IR. So let's say, suppose we had a 1.5 volt battery connected to 15 ohms of resistance. What is the current flowing through the circuit? So I could draw this circuit like this. So the longer line represents the positive terminal. The shorter line is the negative. And this symbol right here is a resistor. So I have a 1.5 volt battery and a 15 ohm resistor. So this symbol is a resistor. So current is going to flow out here. So I have a current. So current is equal to voltage over resistance. The voltage is 1.5 volts. Resistance is 15 ohms. And that'd be 0.1 amps, right? So that means 0.1 amps is flowing out of that circuit. Let's do another question. Suppose we had 2 amps of current flowing through a 10 ohm resistor. What is the voltage difference across the resistor? So we have a resistor which has 10 ohms of resistance, and across it we have 2 amps of current. So this would be the positive side, this would be the negative side. So voltage is equal to current times resistance. So the current is 2 amps. The resistance is 2 ohms. So we have 20 volts. Make sense? So I'll go more into detail tomorrow. Any questions?